Hey, I'm Tito, and I'm gonna explain to you how I actually made the push battle AI evolutionary algorithm thing. First, I actually needed like a training, program. So all I did was actually modify the judge engine over here, which was provided to us, into trainer. And for the most part, this is like the same script, except down here in main, I'm actually running it several times over depending on how many like rounds I want, how many bots I'm running, and the total, generation count, like the amount of generations that I want in a singular instance of this. And also, over in game, I'm also, where is it? Right here. I'm also moving some data along certain places depending on who wins and who loses. So if a bot wins, we're going to gain a score of plus 10. If a bot loses, we're not going to gain anything. And the bot that has the highest score by the end of the generation moves on and copies its data to the other bots. And that's down here. The .evaluate just leads back to training data. And this will actually take care of all the data. So all the heuristics, all of the weights, all the stuff like that. Just a lot of lists. So then what I did for the actual, bot itself, here we have Darwin, which is what I named him because I'm... Anyways, so this is a modification of the original random agent that was provided. And all it does is that it takes the entire board, right here, and assigns values corresponding to a weight, right? So if a value is 0, that basically means that there is no weight attached to it. If it's 1, that means that there is some weight attached to it. If it's 100, that means there's a lot of weight attached onto it. And what the program is going to do is it's going to check every single one of these squares and figure out which one has the greatest weight, or which one has the absolute best chance at being something good for the AI. And it does that by evaluating several different things. This one just goes through and makes sure that it assigns 1 and 0 to all positions that are actually like possible to play on, so that we don't actually like try to place a piece anywhere that is already taken. This one is for assigning neighbors that are basically like your team pieces. So what this will do is that based off of a weight, it'll give a value to all of your neighbors that are in your team, just in case you may want to put pieces there or specifically avoid placing pieces there. And then this one does the same thing except for enemy pieces. This is just a noise algorithm that I didn't end up using, and these are used to actually find the max position or a random assortment of the max positions. And then we're just printing stuff out here for debugging purposes, and this is where we actually return it. And actually, I can actually, let's see, I can do an iteration of training real quick, so I can show you how that works. So first we run player 1, and then we run player 2, and then we run trainer. And as you can see, a bunch of data is being trained immediately. That is 10 bots running basically all at once, doing 10 games each. Normally I run this for about 5 generations. In this case it's only 1, so it's going to go by quickly. Just give it a second. Just a second. Yeah, it takes a while. There we go. And at the end of it, it outputs the winner and the actual associated data that I can use to then alter the values directly and manually of the AI. The most important value is probably this one down here, which is the actual scores of each of the bots. And then right here we have some statistics like the best average score and the best seeds and stuff like that. And that's it. That is how my works.